cannot see you all. This is going to be a little awkward. Hi everyone, my name is Sarah Guthals, and I'm going to be talking to you a little bit about monitoring. Oh, I should have stopped. I should have let that play. Sorry. ADHD, I don't notice those kind of noises. Hi everyone, my name is Sarah Guthals, and I'm going to be talking to you today about distributed tracing, and a little bit about monitoring, and a little bit about Sentry. And before I get started, I want to give you the time during my talk to think about a time when you were trying to find some kind of issue and the logs weren't enough and developer tools weren't enough. And I want to know that story. Like, how did you figure it out? What did you do? And you don't have to say like, I had Sentry distributed tracing. It's just like the horror stories. That's what I want to know. And 3 people who tell me and my friend here, Lazar, who is also from Sentry, will win these custom dumpster fire card games. 3 of them. They're really fun. It's a card game you can play with friends. It's a lot of fun. You only need at least 2 people though, so it's great. All right, let's go ahead and get started. So I'm going to walk you a little bit through monitoring, just really high level. It's not going to be a big, long lecture. I'm going to show you what monitoring looks like in Sentry so that when we get to the fun distributed tracing parts, you kind of know what to expect. Show you a little bit about performance. And then I want to go back in time and talk about why we think we need distributed tracing now. Walk you through that. And then we'll share some links and we'll go have some drinks and food. Sound good? Awesome. First of all, I do want to give a shout out to Lazar, who is also an advocate at Sentry. I lead advocacy at Sentry. And he was the one who wrote the blog post that inspired a workshop, that inspired a lightning talk, that inspired this talk. So without him, couldn't be here. So definitely follow him as well. All right, monitoring 101. We've all had this experience where we get to an app, we get to a website, and we're having a really poor user experience. We're frustrated, and developers are too late to fix it because by the time they realize there's been like a bunch of tickets opened or there's a big Twitter storm or X storm, I don't know what the name is anymore, and we're too late to fix the actual issue before people are leaving, you're losing sales, you're losing customers, all of that. So monitoring allows us to detect issues faster, sooner, when they're actually happening, not when people are reporting them. Give developers something actionable to fix it, and hopefully the majority of your customers or users won't even notice that there was an issue in the first place. So if you weren't sold on monitoring yet, hopefully that'll sell you on it. And if you weren't sold on Sentry monitoring, the benefits of Sentry specifically is that we care almost exclusively about developers, meaning every time we want to give you some insights into why your app crashed or why the performance is slowing down, we give you as much as we can. If you upload your source maps, we allow you to see exactly the line of code that is likely to have caused that issue. We can pull in who made that commit and auto-assign them and auto-alert them in Slack and Discord and Teams and email and I don't know, whatever else, so that you can actually fix the issues, get the person who knows how to fix the issues faster. And it doesn't have to be the person who did the commit. It could be the code owner. So if you have a different group of people who are owning the kind of health of that code after you've committed it, that's fine too. So that's just a very quick crash course in monitoring. Hopefully we know that. Now I'm going to walk you through this very simple app that we built. Don't hate me. It's built with Next.js, but the reason why, one of the reasons why we're here is that my whole team is actually starting this really big project using Nuxt. And so part of why we're here is to share distributed tracing and monitoring with you all, and also to learn from you all about what not to do and what to do for our app that we've just started. So if you want to follow along afterwards, not now obviously, feel free to, but let's just kind of check this thing out real quick. It's a very simple app. It's flashcards. We're going to zoom in here. You can practice them. You can pick a flashcard, learn stuff. Great, awesome. You can add new ones. We can come in here and just be like, cool, awesome, updates, great. Very simple app. Like I said, this is just an open repository, so you can feel free to jump in and check it out, try it out. All you really need is a database. We used PlanetScale. You can use kind of whatever you want. A Sentry account, which I'm going to give you a 3-month free code at the end of this, so you can try it out. Also, we're open source, and you can do self-serve too, so you can try it out. And to just clone it and give it a try. Fairly simple. Okay, so let's see what actually happens in terms of monitoring. I think that's, well, okay, yeah. I have these like title slides just to make sure my ADHD doesn't get confused. So let's see what actually happens in terms of monitoring, because this app is connected to my Sentry account. So I'm going to open up Sentry, and we're going to go into the projects. This is my projects dashboard, and I'm going to hop into this one right here. And this is my flashcards project. I don't know what happened. Literally 10 minutes ago, I had 100% crash-free session, so I'm really mad now, because that was going to be like my joke, but it's falling now. You can see that this is a very simple app. It's not likely to crash very often. Our DB was asleep, which is why it crashed. You get a lot of interesting information right here at the top of kind of this project. You can specify which environment you're using. So if you do want to hook up Sentry in your kind of dev environment and not have to just use dev tools and use something a little bit more, robust. And then you can also separate it out into your production environment. You can also specify a specific time range if you're looking for things that just happened in the last 24 hours because there was a major outage, or just kind of seeing what the health over the last quarter has been. And then there's a myriad of other ways that you can filter through your errors and your performance issues within Sentry, but that's not for this talk now. If you want to know, you can come talk to us or check out some of our other resources. All right, so we can see that we have no issues here, and everything looks good. If we head over to the Performance tab, we can see that we get another type of dashboard specifically focused around performance metrics that you might care about. One of my favorites is user misery. Basically, if your users are experiencing 4 times the thresholds that you set as your thresholds for your application, they're miserable. So that user misery will go up. We can also see that we've got a number of transactions here, and I'm going to dive into that a little bit more later. But the one thing that we did do just now was update a flashcard. Right? We updated the answer to what is the best JavaScript framework, and I see here in plain English, updating flashcard. So that is probably the transaction where we updated that flashcard. And if we come in here, we can see how long things took. We can also see user misery specifically on this transaction that happened. And we can see the number of events. So right here, we've got this one on the 10th, and our timestamp is a little off because it's just time zones and things, but this is the one that we just did. And so we can click into this specific event of updating this specific flashcard, and we can see that we've got this nice little waterfall of what took so long. From the client calling a put took the longest amount of time, which probably is expected. You can determine if this is an appropriate amount of time or if this is something you want to dig deeper into. For this particular event, we can see some other information, like which type of device I was on, which type of operating system, which type of, device, operating system, what browser, and then I was, the specific URL. So in this case, I was doing it development or production mode, but on localhost. We also get this long list of breadcrumbs for everything. It's very, in-depth. And then a bunch of other information. Again, you can apply specific contextual tags or other bits of information to your events, performance and errors, to make this more usable for whatever you need to find out about your apps. Awesome, fairly straightforward. Seems like a no-brainer. Got it, good, awesome. That's performance. Okay, we're like halfway done. We know what performance is. We know what monitoring is. Now we're going to go into distributed tracing. Okay, so we're going to go back in time here. All right. And as our libraries and our frameworks were evolving, our debugging tools evolved as well, right? Hopefully. Back in the days of like Apache servers, we basically had a request, and then that forked a child process, and we could have a log associated with that. Fairly simple. So then if you had an issue with that request, you just go to the log, and then you can look through it, and you have your answer for what happened. Awesome. Perfect. Then we started doing some basic concurrency. So at this point, instead of forking a process for every single request, we started to handle multiple requests in one single process, but in separate threads still. Our logs are still pretty good. They're still pretty useful at this point. We can basically just prefix a log with the particular thread, and then we would be able to follow from like a request down to the log that made sense for having information related to that issue and figure out what the problem was. Awesome. Still okay. But then we started doing some slightly more advanced concurrency. In this case now we've got frameworks that are async, multi-threaded. We've got features and promises, event loop-based framework. It's just kind of, there's messes. Our request can start one thread, which may like not exactly finish, but kick off to another one, and then it's just kind of this big spider web of threads, and then eventually maybe there's some logs, and we can maybe prefix the logs with the thread name, but it doesn't really solve the problem because that's not necessarily the thread that was kicked off. It's just kind of a big jumble, and we don't know now which log file is going to be useful. And we don't want to be searching through log files. Trust me, I've done it. It's not fun. So at this point, we generate a unique ID, right? And we can send that through, and then at least we can prefix and have that information and still maybe find that log and connect to it. Okay, but then it didn't stop, right? Obviously, we're still not just searching through logs right now. Well, maybe some of us are. About 10 years ago, we've got Docker, AWS. We're starting to go into these containerized services. And this makes it just impossible for us to be sifting through logs at this point. Our backend doesn't even live on one single machine, so you don't even know where to go search for these logs. Each container and microservice handles different requests and produces its own logs in whatever formats they want to do. They're just everywhere. You don't know what's going on. Again, these are not fun to go through. If you haven't done it, don't. It's not worth it. And that's when distributed tracing really became important, because now we really did need to start tracing between all of these microservices, all of these just containers, just everything, in order to find where that issue was. So let's rebuild, knowing where we kind of grew to, let's try to rebuild what distributed tracing is really under the hood. Okay, so we start with, we know that it's going to be distributed in nature. We're not going to not have a distributed stack, right? It will be. So we need to define a vehicle to continue to monitor this trace across those distributions. I don't know what the right word there is. So let's call that a trace. Makes sense. Now I'm lost. Yes, perfect. What slide am I on? Yeah, okay, good. Let's delete this one. Okay, 17, right? Perfect. Yeah, so the trace starts with the initial operation, the initial action by the user, right? So it likely will start on the front end. Maybe not. I don't know all of your apps. That's okay. But likely it'll start on the front end. So that's when a trace will start. And what we're going to define here is basically that still like smallest unit of what might be happening. So you can think about this like an HTTP request is a span, or a function call is a span. right? And so we're going to have a number of spans within this first part of this trace. And we're going to create a span right at the beginning of the trace, and that's going to be our root span. You can start to think about this kind of like a tree, or a graph, I guess, no, a tree. Spans need to, like spans will be mimicking the way that our software is working. So a span might need to create or call another span, right? We want to keep the spans really small, otherwise we're, again, running into the same issue. Rather than just passing like simple bits of information, like a string of text across these spans to say where we are, where we're going, et cetera, we're rebuilding this from scratch, so spans can actually have a lot more information than that. They can know who their parent span was, who created them. They can know like what they're creating next. You can even add other things, but you know, at the very basics, we can know kind of the structure of this tree of spans. Okay. I wrote way too many words, and now I'm trying to read them. Doesn't work. So we can keep a set of tags in those spans as well. And those tags can then be searchable, either through something like Sentry, right? And that's where those like custom tags and search bar that I showed at the top, the beginning. So then you can add additional information. So because there might be some spans within this tree of spans that belong to certain types of functions, not the functions in code, but like, you know, this is actually gonna update the database or something like that, right? That might be one thing versus this is gonna call this other microservice. So you might want to apply certain tags to those things. So then that way you can search for all of the things calling that one particular microservice instead. So we can add those to our spans. And then you can decide, hey, this particular type of operation took too long because I can see the length of this particular span, and then not want to do that. Want to fix it, want to make it better. Also, we're going to create a finish operation when a span is done so that we know that the span has completed. Fairly simple. All right. How do we actually distribute this, though? Because that was all happening on the front end. Seems like we know how to do that already. So in this case, you have a particular trace that these spans are a part of, and you have particular operations that are a part of a span. So you have a trace ID, and you have a span ID, and that is very easy to distribute, right? And so that's what we use. And then on the user service, guess what? You still have spans, which also are the same thing. And you can still apply tags. And if it's a microservice that you do not own or something like that, that's fine. But you know, you can still leverage this distribution of I'm making this call now. And so anything that happens after this is a part of that span. Essentially, you can connect all of the things that you're doing within your app through these spans and through these traces. So, quick recap. Basically, distributed tracing allows you to track the entire flow and specifically how long each step in that flow is taking. It allows you to just navigate the entire system of one specific operation that was initiated by the user. It's especially useful if you're building something full stack or using microservices, obviously, but still can be useful otherwise. And it helps you understand the entire performance of your app as well as different components. And so if you are like really bored and looking for something to do at work because, you know, that feature's done and it's written perfectly and has no errors, and you're like, I just want to optimize something, you can go in, check out which part of your app needs optimizing, and focus on that. So I just want to show you real quick basically, this is what a distributed span can look like. So you take that entire span of actually making the update in the database, and we can see that the part that took the longest is here, right? Now, is 975 milliseconds too long for a simple update? I don't know. That's for you to decide based on your app. But now we know that this specific operation is the one that's causing this. And we can start to see some of these English words. I just want to quickly point out where that is in our code. So again, this is just on the repo. Sentry is really hard to be an advocate for because it's actually pretty easy to just use. It's like 2 lines of code everywhere. But I wanted to show those 2 lines of code. Essentially, here is our update function in our front end and our hook, right? And so we are getting our current scope. We're starting a transaction because we're about to update. This is a specific thing that we want to be doing. We're saying we're updating the flashcard. We can see that. Actually, it's above this one because I make a call to this first. But right here, we do a mark. This is one that starts, right? This child span starts and finishes immediately. It takes 0 seconds, and we can see that over here in our dashboard. Maybe 0 seconds. 0.1 milliseconds is good enough. That's our making API requests. And then we can scroll down, add in some headers, grab the trace parent, right? So make sure that we're attaching this to that same trace. And then we can head down here and actually make the call to putting that in the database. And then over in our back end here, inside of our put, we can get the current scope, get the current transaction. We're not starting a new transaction. We're continuing this transaction from the front end. And then we can do everything that we need to do. And then if we finish making checks, so we want to do a quick span for just checking the category, making sure it's valid. If it is, great, finish it. And then we want to do a quick check to make sure everything is valid within the flashcard. And so we are going to start a child span for that. And then if it's good, great, we're done, finish it. Well, that's if it's not good, but here, there. And so that's where you see all of these category check, flashcard check, updated the flashcard. That's basically what I have for you today. There's a bunch of links here, including the links to these slides, which have all these links. If you want, you can get 3 months free with the code VueToronto 2023. We have the original blog post and then also a really in-depth distributed tracing 101 for full stack engineers that I highly encourage you to check out if you're interested in this. And one last quick plug, next week, starting Monday, every single day at 9 a.m. PT, noon ET, we're going to be having a launch week demo. So I highly encourage you to check out all the things that we're launching next week. And you can join at Sentry Launch Week, bit.ly Sentry Launch Week. Thank you all so much.
Can we get another applause for Sarah, AKA Dr. G, for finishing early? You know that means it's extra time for grilling. Look at we got a very anxious audience here that wants to ask questions. Is that correct? First question, hand up. Yeah.
Hello. I have a question. So, what kind of overhead does Sentry add to the application, and does it adjust for its own overhead? And does it account for the client's network speed or connection?
Yes, great question. We have a whole big long doc on overhead specifically because obviously we need to care deeply about that. So I can add this to the deck as well, but if you literally search like Sentry performance overhead, this one should pop up, and I encourage you to go through it. Obviously, there's going to be minimal, but there's not, it shouldn't be enough to where it's causing an issue, because that would be a very bad business model. Thank
awesome,
you.
Great question.
It was an important one.
Here comes another one.
Hey, Yeah, so, well, we use Sentry.
Awesome.
But one of the questions was it's more sampling rates. So we've been sort of tuning it up for like the performance stuff, or tuning it down, and because like sometimes we were catching some bugs, sometimes we weren't because the requests hadn't come in, or it's a rarely used page. So just, do you have any sort of tips on how to decide on that?
Yeah, good question. I know we have some stuff, I'm pretty sure we have some stuff coming out on Monday about sampling rates too. We've experienced similar things where if it's like something that you just haven't seen a lot, sometimes it'll not show up the first time or something like that. But there is a lot of fine tuning you can do both in your code or in the app to help with that. So yeah, fairly complex answer, but we can definitely show you some of the things. A lot of the code that you'll see in the sample repo for distributed tracing, the extra code we had on like transactions, isn't actually required because Sentry works out of the box basically with just kind of running a wizard and you're done. But if you want to get kind of really detailed bits like that, like if there are pages where they're just not getting hit very often and they're critical enough that you want to know, but like, yeah, you can add some extra code there to also kind of capture those.
Thanks for the presentation. It was really cool about being able to follow transactions from the front end to the back end. I didn't know you could do that. But is it possible to do that if you have a different project for your back end? Because we run PHP.
Yes, definitely. Sentry supports like every language and framework. I can't really say every, but like over 100. And yes, you can have one, like things crossing over between all the things.
I do have a question myself, if I may. I'm going to raise my own hand. User misery.
Yes.
Okay, so that's like sounds like a proprietary kind of like metric. And as you sort of like get into that, I also want to ask, because I noticed that Sentry also tracks rage clicks. Now, I'm trying to figure out why you would have a proprietary user misery and not use rage click, since rage click is actually being discussed like amongst sort of like W3C and stuff like that. So.
Yeah, so user misery is more of like an all-around users are experiencing this and are likely miserable. Rage clicks and dead clicks is something that is fairly recent. It's more part of our session replays. I mean, it's not exclusive, but part of our session replays offering, which session replays is a video-like replay of what your users were actually doing on your site. So it isn't taking video, but it does look like it's taking video. It's really awesome. We can show you some demos, but also day 2 of launch week is going to be on session replay. I know I'm just shilling, but it's all free and on YouTube, so there's nothing there. But it's just so you can see what it's like. But we've got some rage clicks and dead click stuff coming out on Tuesday as well for that. But yeah, I think user misery inspired that.
Okay. So do you feel like user misery is something, I mean, since it sounds proprietary, so do you think like it's something that's worth carrying on because it is so proprietary?
I mean, it's just one of the metrics that's in our dashboard. So if you don't want to care about it,
okay,
you don't have to. Yeah, this is the docs that's on it. Again, if you search Sentry user misery, you can come up on this, but it kind of just tells you what, and then you set your own custom thresholds for what that looks like. I think it's still worthwhile for people who want to have just that overall for my entire project or for this entire type of event or something like that. I want to know what my user misery is. It's like a one simple metric.
Super curious.
But yeah, definitely like part of what we're open source.
Yep.
You know, we try to make it for every developer, meaning that you can customize quite a bit and care about what you want to care about.
Yeah. I mean, there's another one floating around called frustration index. So I was kind of like, hey. Okay, do we have any more questions? Thank you very much for that, by the way.
Yes,
Not
definitely.
turning my back.
Thank
do we
you
have
for
any
your
more questions? Thank you very much for that.